this problem here, what we're going to do is we're going to focus on horizontal asymptotes. So for this example, we will go ahead and find the horizontal asymptotes. Actually, there's just going to be one horizontal asymptote. Okay, let's start off with, say, y equals 1 over x minus 2. This is a translation of the function y equals 1 over x. This is a shift to the right by 2 of y equals 1 over x. This is a rough sketch, but what do I see? The horizontal asymptote is the line y equals 0, which is the x-axis. Okay, now how do I know that? Because we've sketched this graph, we plotted points. What is a horizontal asymptote? It's a horizontal line that the graph gets closer and closer to. And we say as x arrow, which means approaches infinity, y approaches 0. So as x gets very large, say x is 1 billion, well, I'm going to subtract 2, but 1 billion minus 2 is pretty close to 1 billion. Then I'm going to have 1 over 1 billion minus 2, which is almost 0. It's not quite equal 0, but it's close. As x approaches negative infinity, y also approaches 0. Put in negative 1 billion. Subtract 2, it's almost the same as 1 billion. 1 over negative 1 billion is very close to 0, not exactly 0. This fraction is never 0 because the numerator will never be 0. Let's do one that's more involved. Y equals x plus 1 over x squared plus x plus 6. Okay, now before I've done problems where I factor, and for doing these horizontal asymptotes, factoring doesn't really help. Okay, so here we have the introduction of a rule. If the degree of the numerator, so I'm shortening this because these are sort of long words in itself. Degree, numerator, is less than the degree of the denominator, then the horizontal asymptote, which you could write just at HA, is y equals 0, x-axis. So an explanation is put in x equals, say, 100. Y would then be 100 plus 1, which is almost 100. The denominator is 100 squared. It's 100 times more than 100. And that's true, you're going to add 100 here. Maybe you would subtract it, maybe you'd add it. But this starts getting close to 0. It's just that this guy in the denominator, when you square it, makes it 100 times bigger than 100. If I put 1 billion squared is 1 billion times more than 1 billion. So the answer to this problem is the line y equals 0, x-axis. So without doing a whole lot, we just sort of look at it and say, okay, the degree of the denominator is greater than the degree of the numerator. Another way to look at this too is that for large values of x, x squared is so much bigger than x. Like a billion squared is so much bigger than just a billion. So for large values of x, you can just sort of ignore these terms like 1. Like say you have a billion, you add 1, it's hardly any different, right? So you just ignore those, and we get x divided by x squared simplifies to 1 over x. And we know 1 over x has asymptote, horizontal asymptote 0, y equals 0. Now let's look at y equals 2x plus 1 over x minus 1. We're going to use this rule. If the degree of the numerator equals the degree of the denominator, then the horizontal asymptote is the ratio of the lead coefficients. So the answer is horizontal asymptote, the line y equals 2. It would not be correct to write just 2. It's not. It's a line y equals 2. Explanation is long, but let's go for it. Although, I don't think I can do it on just this piece of paper. Possibly. Need a new sheet of paper, it seems. Okay. Do this little trick here. Explanation. Explanation is long division. We don't want to do this each time, but this is explanation. So I take 2x plus 1, I divide by x minus 1, 2 times x gives us what we need, 2x minus 2, I add the opposite, so I get 3. So what this tells me is that y equals 2x plus 1 over x minus 1 is equal to 3 over x minus 1 plus 2. And what this is a shift up of the graph 3 over x minus 1. So, okay, let's just write y equals 3 over x minus 1. That's this. How do I know that? Because that's a translation to the right of 1 over x minus 1 multiplied by 3 makes it a little bigger. But the 2 here shifts it up, and that shifts the horizontal asymptote up. So I'm going, it's a little bit overkill here. I'm sketching the whole graph. It would be sort of good if I see what happens when x is 0. When x equals 0, y is negative 1, just to get a good picture here. Okay. So that's the explanation. This guy here, this goes to 0 as x goes to infinity. So I'm getting something that goes to 0. Let me write 0 right there. This guy goes to 0 as x goes to infinity, and so you're left with something very close to 2. That's our explanation. But we don't want to do that each time. All we want to do is look for the lead coefficients, which are 2 over 1. So let's see if we can do a really quick one. Find the horizontal asymptote y equals 3x squared plus 1 over 2x squared plus x minus 6. Okay, so what do we have? Degree of numerator equals degree of denominator. So the answer is the ratio of the lead coefficients. Y equals 3 over 2. And you have to write in this form. That's a line. So it's, you know, it's even better if you write the line. Well, that's the answer there. Okay.